The notes for today are on section 9.3, trapezoids and kites. The first thing I want you to do is mark on your paper that these two quadrilaterals are not parallelograms. Trapezoids have four sides and kites have four sides, but they're not parallelograms because in them both pairs of opposite sides are not parallel to each other. A trapezoid is defined as being a quadrilateral with exactly one pair of opposite sides parallel. So in a trapezoid, you have one pair of opposite sides parallel, but the other pair of sides cannot be parallel. There's a second property of trapezoids, though, that says that each pair of lower and upper base angles is supplementary. So that means that this angle here and this angle here equal 180 degrees when you add them together. And then over here, it means the same thing. It means that these two angles, when you add them together, those ones equal 180 degrees. And that's because of the nature of parallel lines. In addition to the two properties of trapezoids, there's a special kind of trapezoid called an isosceles trapezoid, where these two sides are still parallel, and the same thing's true about those angles equaling 180 degrees, but in an isosceles trapezoid, these two sides are congruent to each other. In an isosceles trapezoid, the diagonals are congruent to each other as well. They don't bisect each other, though. And then it says that the lower base angles and the upper base angles are congruent to each other. So this angle and this angle are the same, and then this angle and this angle are the same in an isosceles trapezoid. In question number 3, it tells us that from A to C is 19.3 meters, so that's this whole distance right here. And then from B to E, so just this little part right here, this part's 8.1. And we're being asked to figure out how long is it from D to E, so we're trying to figure out this part. Notice that on this trapezoid, these two sides are parallel and these two sides are congruent, which means it's an isosceles trapezoid. And so that means that the diagonals are congruent to each other. So if this one's 19.3, the whole thing, it means that this one, the whole thing, also has to be 19.3. To figure out how long it is from E to D, we're just going to subtract these two numbers. So we'll get 11.2 meters as our distance from D to E. On question number 4, we're being asked to find the value of each angle. So we're told that angle P is 77. Look at the picture. These two sides are parallel, and these two sides are congruent, and so that's what makes it be an isosceles trapezoid. In an isosceles trapezoid, the lower base angles and upper base angles are congruent. So that means that if this angle right here is 77, it also means that you know that angle Q is 77 because they're on the same parallel side. And then on the other side, you have to use one of the properties of trapezoids, not isosceles trapezoids, which says that each pair of lower and upper base angles is supplementary and adds up to 180 degrees, and so that's how you would get the measure of angle S is 103 degrees. And then, because it's an isosceles trapezoid, you know that the measure of angle R would also have to equal 103 degrees. So in an isosceles trapezoid, these two are going to be the same, these two are going to be the same, these two are going to add to 180, and then these two are going to add to 180. On problem number 5, we're told that JL, so this diagonal is 3y plus 6, and then KM, so this diagonal is 22 minus y. It says determine the value of y that makes the trapezoid isosceles. So if it were an isosceles trapezoid, then the diagonals would be congruent. And so for this one, I could set 3y plus 6 equal to 22 minus y, and I can solve this for y. And so when I follow the steps to go through and solve this for y, I'll get y equals 4. So y equals 4 is the number that would make the diagonals congruent to each other, which would make this trapezoid be an isosceles trapezoid. Besides the sides of the trapezoid and the diagonals of a trapezoid, there's another segment in the trapezoid that's called the midsegment. It connects the midpoint of the two legs of the trapezoid, so not the two sides that are parallel. It connects the middle of this side to the middle of this side over here. The trapezoid midsegment theorem says that the length of the midsegment of a trapezoid is equal to the sum of the bases divided by 2. The bases are the parallel sides, so you're going to add up the lengths of the two parallel sides, and then to figure out how long the midsegment is, you're going to divide by 2. So for this one, I'll do 10.3 plus 12.5. It doesn't matter which one you put first and which one you put second, and then I'll divide that by 2 to figure out the length of the midsegment. And so for this one, I'll get 22.8. and then I'll divide that by 2, and so I'll get that the length of the midsegment for this one is 11.4. Question number 7 is a little bit different because they give you this side, but then this side's missing, and they tell you that the length of the midsegment is 19.7. So 22.4 plus the one that you don't know, when you divide that by 2, you're going to get 19.7 as your answer. So you have to set this one up a little bit differently when you're solving it. I'll multiply both sides by 2 to solve this one. Multiplying by 2 makes the 2's cross out, so you'll get 22.4 plus x is equal to, and then on this side I'm going to multiply the 19.7 times 2, so 39.4, and then to finish solving I'll subtract the 22.4 from both sides. And so for this one I'll get that x, the side of the trapezoid that I wasn't sure what the answer was, that's the one I wanted to solve for, I'll get 17 as my answer. So the length of segment FG will be equal to 17. The last kind of quadrilateral that we're covering in the notes this week is called a kite. And a kite is a quadrilateral with 2 pairs of adjacent congruent sides. So it's the ones that are next to each other that are congruent. In a kite, these 2 sides are the same and these 2 sides are the same. It's not the ones that are across from each other that are the same. That's part of the reason why a kite is not a parallelogram. In a kite, the diagonals are perpendicular, and then this gets a little bit technical. The non-vertex angles are congruent, so that means that this angle here and this angle here are the same thing. The vertex diagonal bisects the other diagonal, so that means that this piece and this piece are equal to each other. And then the last thing says the vertex diagonal bisects one pair of opposite angles. So this angle gets cut in half, and then over here this angle gets cut in half, but I marked them differently because this angle and this angle are not themselves the same. Question number 8 gives us some information about the kite. It's always good to mark the information on the picture. So angle BAE is 32, that's this one right here, and then angle BCE, this one over here, is 62 degrees. They tell us it's a kite, and they want us to find the measure of each of these different angles. We're going to have to use the fact that in a kite, just like in a rhombus, the diagonals are perpendicular to one another. And knowing that will help us answer the question. Look at the first one that we're being asked to find. We're being asked to find the measure of angle CBE. So for A, we're trying to find this angle right here, which is an angle that we don't know. But we know that this angle right here in the middle is already 90 degrees. And then we know that this angle right here is 62 degrees. So what I can do to solve this problem, there's a couple of different ways I can set it up. We know that in a triangle, all 3 of the angles always add up to equal 180. So for this one, I can say the angle that I don't know, plus the angle that I do know, plus the other angle that I do know, because I know the diagonals are perpendicular, are going to add up to equal 180. I can combine like terms on the left, so that's going to give me x plus 152 is equal to 180, and then I'll minus the 152 from both sides. So for this one, the measure of angle CBE, I'm going to get that it's equal to 28 degrees. So the measure of angle CBE would be equal to 28 degrees because that's how many degrees would be left over for this angle if this one was 90 and this one was 62. And then for B, I'll do the same thing. On this one, I'm trying to find the measure of angle ABE. So for this one, I'm trying to figure out how big this angle is right over here. And so to do that, I'll do it the same way. I'll say the angle I don't know, plus 32, plus the 90 in the middle because it's a kite, so the diagonals are perpendicular. I know that in this little triangle, those have to add up to equal 180 degrees, and so I'll solve that for y. And so when I solve that one for y, I'll get y equals 58 degrees, which means that the measure of angle ABE is equal to 58 degrees. So even though it's not a triangle, you're using properties of triangles to help you solve to find the missing angles in the kite. And for this final problem for number 9, it says use the kite to find the measure given this information. So the first thing we want to find is the length from A to B. So for this one, I've marked the picture with the given information. You also want to make sure you remember that because it's a kite, you know that the diagonals are perpendicular. In a kite, if ED is given as being 6, that means that from B to E is also 6. And so to solve to find the length from A to B, I can use the Pythagorean theorem. A squared plus B squared is equal to C squared. Remember, it doesn't matter which one goes in for A and which one goes in for B, but the C always has to be the hypotenuse, and that's the one that's opposite the 90-degree angle. And so I'll go through, I'll square 8, I'll square 6, and that'll give me 100 equals x squared. And then to solve to find out how long it is from A to B, I'm going to take the square root of both sides. So for this one, I'll get x equals 10 because the square root of x equals 10. So that means that from A to B will be equal to 10. over here, I'm solving to find the length from C to D, which is this segment over here. I'll call that Y on the picture. So again, when I do the Pythagorean theorem, I can put the 4 in for the A or the 6 in for the A, and then I could put the 4 in for the B or the 6 in for the B, but the Y is the hypotenuse of that right triangle. That's what I'm trying to solve for, so that one will have to go in for C. And so on this one, you'll get 52 is equal to y squared. When you take the square root of both sides to get the y all by itself, it's very common in the Pythagorean theorem that you get numbers that are decimals, and so that's going to be the case on this one. You'll type in the square root of 52 into a calculator. Now the directions don't say what they want us to round to, so for the purpose of this question, I'm just going to round it to 2 decimal places. So it would be approximately 7.21. So the length from C to D would be approximately 7.21, and that would be the answer for that one right there.